Assalamu alaikum warahmatullahi wabarakatuh. Hello. Welcome to our YouTube channel. So in this YouTube channel, we'll be trying to go through a certain paper that a student sent to me. And this paper is a physics question paper for advanced level. Yeah. And the paper is consisting of 9 questions. So we'll see how to go through them, and maybe we can do 2 videos for them, or at least a single video, but let me see. We'll go as we are going. So this is the first question. It reads, what will be the acceleration? Let me change my pen. What will be the acceleration due to gravity on the surface of the moon with its radius as 1/4 the radius of the earth and its mass as 1/80th the mass of the earth? That is the question. So don't be surprised. You can read physics questions at least 3 times before it makes sense to you. Okay, let us read it again. What will be the acceleration due to gravity on the surface of the moon with its radius 1/4 the radius of the earth and its mass as 1/80th the mass of the earth? Okay, let us now read it and be taking some data that we will need. What will be the acceleration due to gravity on the surface of the moon? That is acceleration due to gravity of the moon equals to question mark. What is it? With its radius, so radius of the moon is equals to 1/4 radius of the earth. That's what they have given to us. And its mass is 1/80th the mass of the earth. So mass of the moon is 1/80th mass of the earth. So you have to calculate the acceleration due to gravity of the moon. So now I'm seeing the relationship between distance, acceleration due to gravity, and mass. So in which topic, or in which equation am I going to use, and from which topic, and how can I even come up with my own equation to use it that it should be valid and it should give me the right answer? And how should I do it? So well, if you can remember Newton's law of gravitational motion is simply talking of that every particle attracts every other particle with a force which is directly proportional to the product of their masses and inversely proportional to their square of their distance of separation from center of masses. That is a force that exists, that if there exist 2 particles, let us put like this, m1 and m2, let us link them like this, a distance r, that there is a force that exists between those 2 particles, which that force is directly proportional to the product of the masses, that is m1 m2, all on the distance of separation from their center of masses. Please, from their center of masses, not the distance of the separation from their outside, from their center of masses. So it means if I remove the proportionality symbol, I'll put a proportionality constant. In that case, Newton called it G, m1 m2 r squared, and by experiment G has the value 6.672 times 10 to the negative 11 Newton meter square per kilogram square. Please always try to remember with the unit. That is the difference between physics and mathematics. We work with the unit here. Okay, so this is the formula that I know that can relate masses and force. Now they're asking us for acceleration, and I know that force also has some relationship with acceleration. If I know force, I will obviously get the relationship between acceleration. So how do we go about it? Let us first try to imagine it. Let us say this is the moon. I want to determine the acceleration due to gravity on that moon. Let us say consider a certain particle on moon. Let me change the color to green. Let us say we have a certain particle on moon. This is the particle of mass m1. This is mass of the moon. So these particles will also attract each other with same force of attraction, that is from their center of masses. That is it, a distance r. That force have to be equal to Newton gravitational constant, mass of that particle, mass of the moon, all on their distance of separation. There is that force that is acting between them. But they tell us that this particle which is on moon, it will also have its own weight force. If it is on moon, it will also have its own weight force, and weight is equals to what? Mass times acceleration. In this case, we are on the moon, so it will be mass times acceleration in moon. So that will be the weight of that object. And if this object is lying on the moon, and we consider it to be a very, very thin mass, that its radius of the object is neglected, that we can neglect this distance and consider that the distance from the center of the mass to the center of the moon is equals to radius of the moon. If that's the case, then we could say that F, this force here, F will be equals to G m1 m2 over radius of the moon all squared. And that force have to be equal to the weight of the object, because the object is not penetrating inside. It means that the gravitational pull of attraction, that F, is equal to the weight. And if that happens, then G m1 m2 all over radius of the moon all squared. I can put m2 as mass of moon, is equals to mass of the object and the acceleration due to gravity of the moon. From here I can divide both sides by mass of the particle, and we see it cancelling, and we have that G moon is equals to the Newton gravitational constant, mass of the moon, all divided by radius of the moon all squared. This is the formula. Please let us not be cramming formulas. Try to reason how the formula can come about. So this is the formula: G equals to G mass of the moon, all on acceleration, all on their distance of separation, which is radius of the moon. We have been given that radius of the moon is equals to 1/4 radius of the earth, and mass of the moon is equals to 1/80th mass of the earth. So from there we can say that the acceleration due to gravity in moon will simply be equals to Newton gravitational constant, we know it, mass of the moon is 1/80th mass of the earth, all dividing by radius of the earth, radius of the moon, which will be 1/4 radius of the earth, all that squared. And from there you can substitute, and if I can remember, radius of the Newton gravitational constant is 6.672 times 10 to the negative 11 Newton meter square per kilogram square, dividing times 1/80th mass of the moon is 5.94 times 10 to the 24 kilograms, mass of the earth, all that is being divided by 1/4 times mass. Radius of the earth is 6,400 kilometers, but we need the SI unit in meters, so times 10 to the power 3 meters, but all that square, don't forget to square it. So from here you will just substitute, and you have your acceleration due to gravity in the moon. I'm not using my calculator here, so we can just substitute. And let us first see, we are looking for acceleration, and the unit for acceleration is meters per square second. This should be our guide. Are we having meters per square second here? Let us see. This is kilograms here. This is kilograms. This kilograms, mass of the earth, will cancel with this one of these kilograms on Newton gravitational constant, and will be left. Let me just write the unit here. Unit for G is simply Newton meter square per kilogram squared times mass of the earth, which is in kilograms, all dividing by their radius squared, the radius square, which is meter squared. So we see clearly that mass of the meter square is cancelling with meter squared. Kilograms is going with this. We are having per kilogram will be left. So in other words, we are now having the Newton per kilogram, and Newton from F equals to MA. Newton is kilogram meters per square second times per kilogram, and you see it giving you meters. I see it giving you meters per second square. So if you substitute it, that will be the answer. So that's how you are supposed to do that one. So in this video, I will just try to talk about it, and we see how to going. Then let us see how to analyze the next question. The next question is saying that the acceleration due to gravity of the moon's surface is 1.67 meters per square second. If the radius of the moon is 1.74 times 10 to the 6 meters, calculate the mass of the moon. Use the known value of g. Okay, what have they given us here? They are saying that the acceleration due to gravity at the moon surface is 1.67 meters per square second. So acceleration due to equation 2, exercise 2. So acceleration of moon is given to us as 1.67 meters per square second. 1.67 meters per square second. Okay, then they also say that the radius of the moon is 1.74 times 10 to the 6. Radius of the moon is 1.74 times 10 to the 6 meters. Let's calculate the mass of the moon. Use the known value of g. So they're already telling us that we'll still use the same procedure that we use up there and still derive this same relationship, a relationship that will give us, we'll be having the acceleration due to gravity, the mass, and the radius. So now they are giving us acceleration due to gravity and radius, asking us for mass. So we'll just go ahead and substitute. So we have seen that we already said from above. If you don't, you can still derive it, you can test yourself here. So g of moon is g mass of moon on radius of moon all squared. So here we can solve for mass of moon. So g of moon, I can cross multiply radius of moon all squared is equals to g mass of moon, and from there we can have mass of moon is equals to g of moon radius of moon all squared all over g, and mass of moon will simply be 1.67 meters per square second multiplied by, what did they say? They said the radius is 1.74 times 10 to the 6 times 1.74 times 10 to the 6. Don't forget to square it, meters, and then you square everything, all divided by 1. Is it 1.67? 6.672 times 10 to the negative 11 newtons meter squared per kilogram squared. It should be like that. Okay, so if it's also substitute here, you just simply have your mass of the moon. I can still test with the unit. You make sure mass of the moon is resulting in kilograms. So it tells you that should also be your own guide. So that is how we have to do this one. Let us see on the third one. The third question. A spaceship is launched into a circular orbit close to Earth's surface. What additional velocity has now to be imparted to the spaceship in the orbit to overcome the gravitational pull? Radius of the Earth equals 6,400 kilometers and g equals to 9.8 meters per square second. Okay, so they are telling us that, let us try to put it, that a spaceship, so exercise 3, a spaceship, let us say this is our Earth, it is spherical, I don't mind the circle. I'm sure this microphone can draw a spherical shape out. I can remember it. So let me say this is it. Voila. So we will draw a circular object. Okay, so this is the object here. Let's switch it off. So this is the object here. Let us say this is a spacecraft. It is trying to move let us say this is moving with an angular velocity, let us say omega. As it is moving round this circumference of the Earth, there should be some force that have to keep it in motion, but there's also a force which is trying to pull it, as Newton is telling us that there's that force of G which is directly proportional to this force. That force is trying to put it down, but it is also trying to go round. For it to go round now, it will need what? a certain force that keeps it round, and that is the centripetal force. And for this to happen, then the centripetal force have to be equal to the Newton gravitational force for that object to be able to continue that path. If the centripetal force is less than the gravitational force, then that object will be forced to fall into the earth. I'm sure I'm making some sense. So now the centripetal force by definition is given by mv squared over r, where r is radius of the circle which is rotating. Now is our earth, so it will be radius of the earth, and that have to be equals to the Newton gravitational force, which is g, m, mass of the object, g, mass of the object, mass of the earth, all on radius of the earth, all squared. So these two forces have to be equal to each other, and from here we can see that the mass of the object is going, and we will now be seeing that v is equals to the square root of g, mass of the earth, radius of the earth, all on radius of the earth, all squared. I've simply carried this r on the other side. I've been taking the square root, and now from here we see that v is equals to r. We know what did they give us? We know they gave us radius of the earth to be 6,400 and g is 9.8 meters per square second. And there's something again here, they didn't give us the mass of the earth. Me, I know the mass of the earth. If I substitute, I'll have it, but they're giving me the acceleration due to gravity. I know that from what we just earlier derived above, we said that what? We said that acceleration due to gravity g is equals to g mass of the object, and that. So I can go ahead and substitute that quantity as g. So here I will be having that v is equal to the square root. This quantity here is my g, so I'll just substitute that this is g and the radius of the earth, and that is all. Because v will simply be the square root of 9.81 meters per square second times the radius of the, which is 6,400 times 10 to the 3 meters. You don't square it here, you simply multiply that and you take the square root, then you have the value of that speed or that velocity. Okay, then for the other question is saying that a bullet of mass. So the video is long, it's already lengthy, so I will maybe make another video on this, on the second one. Let me just pause the video here and see you on the next video. Thanks for watching. So if you need the question paper, or if you can screenshot it from here, good and fine. Like, we'll do much on physics before you write your GC exam, so do well to follow along. You can have your book, and if you need any problems, you can join our WhatsApp forums where we are helping students, and you can contact me through my numbers. Here is my number: 651-684870 or 699-281457. So you can join me there, you can contact us, and we can add you into the groups where you will be having help with many other students in the country, almost all the regions. And when there are problems, when we are free, we also support you guys. So thanks for watching, and